Assalamualaikum and greetings to all. Today's topic is on double integral in polar coordinates, where instead of x and y, the variables that we use will be r and theta. So this is the relationship between xy with r and theta. So x is equal to r cos theta, y is r sin theta, and x squared plus y squared is r squared. Tangent theta is y over x. This is obtained from this triangle here. So let's say you have a point P and the coordinate is xy, meaning that here we have x and here we have a y. Okay, so from using Pythagoras theorem, we get x squared plus y squared is r squared. So that's the relationship between xy with r. And then from theta here is measured, the angle is measured from the positive x-axis. From positive x-axis in an anti-clockwise direction. So from this triangle, we can get that cos theta is equal to adjacent, which is x, over hypotenuse, which is r. So from here, we get x is r cos theta, which is the first relationship there. And using the same technique for sine, then we get this. And here we have tangent theta is opposite over adjacent, so we have that. Okay, and from here we get this is, as you know, I think most of you know that this is really an equation of a circle of radius r, and the center of the circle is at the origin 0 0. Okay, so from now on, if you have r equals a constant, okay, if you have r equals a constant, what you have is really a circle of radius r, and the center of the circle is at the origin, which is at 0 0. Okay, let's sketch a few r here, r constant. So for example, you have r equals 4. So this is really x squared plus y squared. Remember, that's the relationship between x and y. So here we get x squared plus y squared is 4 squared, which is 16. So this is a circle of radius 4 centering at the origin. So here we have, let's say that's a 4. There's a 4. It's an ugly circle. So we have 4, 4, negative 4, negative 4. So another name for that is r equals 4. Or you can use this equation, x squared plus y squared equals 16. So 16 is really r squared. And let's say we have, oops, I better change the color. Okay, let's say here we have a 2, a 2, 2, 2. Then we have another circle of centering at 0 0. So let's say that's a 2, negative 2, negative 2. So the equation of that circle is r equals 2. Or in Cartesian, it will be x squared plus y squared equals r squared, which is a 4. So this one is in Cartesian, and this one is in polar. Okay, so keep in mind, bear in mind, remember, if you have r equals a constant, that really represents a circle of radius r centering at 0 0. Okay, now let's look at how we measure theta. Okay, theta is measured from the positive x-axis in an anti-clockwise manner. Okay, so for example, before we have r constant, so now let's look at theta constant. So theta constant, oh sorry, I better use black. Okay, theta, first of all, let's look at how theta is measured. Theta is measured, so it's an angle from the positive x-axis in anti-clockwise direction. But if it's measured in a clockwise direction, then your theta will be negative. Okay, so now let's see what happens if you have theta as constant. So theta constant in 2D really represent a straight line. A straight line, not horizontal or vertical, a straight line from the origin. Okay, so for example, keep in mind that theta is measured from positive x-axis in anti-clockwise direction. Okay, let's say here we have xy plane. Okay, so on the positive x-axis, we don't have any angle there, so another name for that is theta equals 0. Okay, now let's say here we have 45 degrees angle, or pi over 4. It's right in the middle there. So this the angle, or the equation for that straight line, which comes from the origin, starts from the origin, this is theta equals pi over 4. And the positive y-axis, well, if you measure an angle, that would be pi over 2, or 90 degrees. So the equation for that, equation for that positive y-axis would be theta equals pi over 2. And I'm running out of color. Okay, let's try blue. The negative x-axis, if you measure from the positive x-axis, that would be pi, or 180. So this line here is theta equals pi, and you know the drill. So this one would be theta equals 3 pi over 2. And of course, if you have one circle, one rotation, then you'll go back to the positive x-axis. So if you have one rotation, then you will go back to the positive x-axis. So you can call this theta equals 2 pi, meaning that you go one rotation there. So remember, if r is a constant, what you have is a circle, the same radius as that constant, and the center of that circle is at the origin. But if you have theta equals a constant, what you have is a straight line that starts from the origin, and the straight line has an angle between the positive x-axis with the same constant there. But of course, if you measure your angle in clockwise direction, then the value for theta would be negative. So for example, here if we measure from positive x-axis in a clockwise direction, like so, so this line is theta equals negative pi over 2. I think you've learned this in high school. Alright, now back to our note. Okay, so now we're gonna go to double integral in polar coordinates. Okay, so what we're concerned now is we want a function fxy, or if we're using polar, then we cannot use r, we cannot use x and y, it's going to be r and theta, and we want to integrate over a region. So the next step is to find what is dA in polar coordinates. Okay, so remember from before, from before, where you have, oh dear, okay, hang on. Remember from before, when you have Cartesian coordinate, where it can be used to find area of a region, is where you partition your region into rectangles, and then you get the value of the area of one rectangle, and then you add them up, and then you at the end you get dA is really dx dy or dy dx. So the technique is to partition your region into small rectangles, get the area of one rectangle, and then you add them up. Okay, so we're going to do the same process as in Cartesian, but we're using polar, meaning we're using r and theta instead of x and y. Okay, where are we? Polar coordinates. Okay, here. So now we have an area. Okay, so here we have area or region R. So we're still on the xy plane. Right, so now we have a region. Okay, remember how we measure R. we measure r. R is considered as r constant is considered as circle. So here we have one circle, okay, and then I'm gonna draw only part of a circle. So we have another circle, another circle, another circle, okay. So let's say this is r1 and this is r2 and so on, but the distance between the two is the same, so I'm going to say this is delta ri, okay, the distance between these two circles. All right, and then for theta, we have, remember theta is measured from the positive x-axis, so here I have theta 1, theta 2, theta 3, theta 4, and so on, and the angle between the thetas are the same, so I'm going to say that this angle here is delta theta j, let's say, okay. And then we want to find the next step is to get area of one wedge. Well, this is really called, it's called polar rectangle but it's not really a rectangle, but we call it polar rectangle, so something like that, okay. It's called polar rectangle, not regular rectangle, or we can call it wedge. Oops. All right, so the task now is to find area of that one rectangle, polar rectangle. Okay, remember for circle, if you have a circle of radius r, area of that circle is pi r squared. Okay, now let's say you have, instead of circle, you have a wedge. Okay, so here we have one, so we have r there. The radius is still r, but the angle now is theta. So we want area of that wedge. Okay, so we have one wedge there. Okay, so remember for the whole circle, the angle is 2 pi. So if the angle is 2 pi, the area is pi r squared. But now our angle is theta. Oops. Our theta angle is theta, so it should be pi r squared over 2 pi and then theta. So that would be r squared theta over 2. So area for a wedge is r squared theta over 2. Okay, so we're going to use this formula. So area for a circle of radius r is pi r squared, but area for a wedge, a sector there, is called, now area of a sector is r squared theta over 2. So r is the radius. Okay, now back to our wedge here, or polar rectangle here. So we're going to get the area of that region there. So where is our, okay, here we go. All right, so this is finding area of that shaded region, which is really part of a sector, not the whole sector, part of a sector. So to get the area is, we need to get area of a bigger sector minus area of a smaller sector. Okay, I'm gonna call this J, because I'm using J before, so this one is J. Alright, so we want to get the area of that shaded region. So area of a bigger sector minus area of a smaller sector. The difference between these two sectors are the radius. The angle is the same. The angle is delta theta j, but the radius is different. Okay, so remember the formula is pi r not pi, the formula is r squared theta over 2. Okay, so using that formula, area of a bigger sector would be a half. Radius is ri plus a half delta ri, square that, and the angle is delta theta j. And then minus the smaller sector, area of a smaller sector, the difference is just the radius. Now it's going to be ri minus delta ri over 2. So we need to square that. And then simplify this. We end up with delta theta I over 2 times 2ri minus, multiply with delta ri. That should be a j, sorry. And then we end up with this. So area of that sector there is equal to Ri delta Ri delta theta j. And then when we want the area of the whole region, we have to sum this up. Okay, sum these two up as well. Oh dear. Okay, so area of the whole thing is going to be summing up the area of the wedge, which is really summing up Ri delta delta theta j I from 1 till n, let's say j from 1 till m, and then doing that we end up with dA. Okay, so dA, when we get the limit instead of, now to get this more accurate, we have to let delta Ri and delta theta j to be very, very small, close to 0, similar to double integral. Where is it? Okay, similar to that one. We have limit of summation, and then that will be changed into integration. So limit of summation when n goes to infinity, m goes to infinity, so this will be changed to integration. So same thing with our bit here. So now we have r dr d theta, and then we have the integration. Okay, so we have r dr d theta. Okay, or it can be done in different way, r d theta dr. Excuse the background noise there. Okay, so now we know. Oops, next page. Right. So for we have a theorem here for on polar rectangles. See that we have rectangles because it's not really polar rectangle, because it's not really rectangle. So here your region R is points r theta. Here r is from a constant to a constant. So here we have r equals a, that is a circle, ugly circle, I know. And then we have another circle, r equals b. So we have another circle, r equals b. And then we have theta equals alpha. And then we have theta equals beta. So from those four equations, we end up with this region, which is called polar rectangles. So if it's polar rectangle, the order of integration, remember before dA is r dr d theta, or r d theta dr. So here, if your region is polar rectangle, then the order does not matter. You can integrate with respect to r first and then theta, or theta first and then r. So now let's look at the limits. So for theta, it's from okay, I'm gonna erase this bit. Okay, so theta is gonna be from alpha to beta. It's going to be from alpha to beta. So here, if you want to know which one is the lower limit for theta, you just draw an angle from the positive x-axis in a anti-clockwise direction. Okay, so you can see that the one it touches first is this line, which is governed by theta equals alpha. So that would be the lower limit. And when it touches last is this line, which is governed by theta equals beta, which is the upper limit for theta. And to determine the limit for r, remember r is a circle, starting from the origin. So what you do is you draw a straight line from the origin across your region, and the one it touches first would be the lower limit for r. So in this case, r equals a, that's the lower limit, and the one it touches last is the upper limit for r, which is in this case r equals beta. The main point is, if your if your region is polar rectangle, then order of integration does not matter. You can integrate with respect to theta first and then r, or vice versa. But remember, dA is r dr d theta or r d theta dr. Okay, I'm going to show you examples later. Thank you.